Hello guys, so today I'm going to explain the typical structure of a galaxy. Before I talked about, what did I talk about? I talked about the solar system, a typical solar system, what sort of structure it can have, a typical one. So now we'll go the next level, which is the galaxy. So a galaxy is a massive, oh, wrong one. It's a massive collection of stars and other stuff. So, if you can imagine a galaxy, typically they have a central bulge, um, which contains usually the a lot of stars. So in fact, if I do it a bit better than that, so there's a lot of stars in the center because usually that's where all the where it's focused, towards the centre, all the mass, and yeah. There's usually a lot of stars in the centre. It can depend though. This depends on what type of galaxy, but generally it's all the stars at the centre, and generally at outskirts you'll have less density of stars. So if we just oh, if I put there and there. Now, this is not to scale by any means. This would be absolutely massive, this galaxy, right? And these stars would be far smaller. Like, so, like our Milky Way galaxy, for example, is about uh, at least 100 billion light years across. So if I drag this is talking about across. It's probably more. That's minimum. So 100 billion is a lot. So yeah, it's a lot. So 100 billion light years. So it's 100 with 9 zeros after it. So yeah, very large place. What you also get with a lot of big galaxies, you get something called supermassive black hole at the center. So, uh, so usually these supermassive black holes, if I fill that in, I'll get there. Yeah. So usually we have a supermassive black hole at the center. Now these black holes are massive. Not like massive in terms of really large, but how much mass have we got? So mass is how much stuff is inside. Doesn't have to be related to volume, which is what we might think of size, but when we talk about mass, how much stuff is inside. So it has a lot of stuff in a small sort of volume. So not tend to not all the galaxies have them. It's just the big ones that generally have them. So if I just move this over to great man, yeah, I'll do actually. So yeah, generally the big ones galaxies have a supermassive black hole. Usually there are different types of galaxies. So you have spiral, you have elliptical, and there's other types as well. I'll talk about that in another video though. This is more like just a general overview. But the one we live in, the Milky Way, is a spiral. So all the cloud and dust, it's not just equally spread out like all the cloud and dust. It kind of just forms a spiral where the spirals themselves kind of have a bit more than the ones that are not part of the spiral. It's quite interesting actually how it works. But yeah, and where I'm quite if you wanted to determine where we are in our galaxy, so if you imagine this is the Milky Way, we would tend to be, if I do a different colour, we would be about here on this sort of area, because remember all the stars and everything, and even the stars in the centre will orbit the centre. So yeah, so we tend to go like that. But this is a good place because generally, if we were in quite really close to the centre, it'd be a very chaotic place. Too many stars all over the place, and the outer bit here is it's got not much dust and gas, and therefore it'd be difficult to form stars like ours. We just probably get red dwarfs, very small stars, not very good ones that are hospitable for life. So yeah. So we've got black holes. So we've got supermassive black holes. We've also got other like black holes as well. No. So like yeah, like black holes that like smaller ones. Usually these smaller ones, they come from the collapse of huge stars, so they roam around. You've got neutron stars. So yeah, you've got some neutron stars. They are from more, shall we say, not from supernovas that produce black holes, but they're from not as powerful supernovas. Because the most massive stars will produce black holes, but then stars that are not as massive but still are massive will produce neutron stars. And I've also heard of like possible stars like lepton stars and quark stars too. But we'll discuss this in another video. But like black holes, in a similar sense, neutron stars are very dense, very dense objects. Black holes are by far the most dense, but neutron stars are dense, but not that dense, if you know what I mean. And they actually have a structure, whereas a black hole, it don't really have a structure to it. It's not really made of matter as such. It's kind of all the mass is focused at a single point. But we can get to this in future videos. So yeah, if we draw some lines, so if I can put, I think they've got a name to these, but I'm not sure what they are. But they're like smaller versions of black holes, or the average version. And they can be about 3 times the mass of our sun. Yet they can be really small compared, like the size of Earth. So yeah, very dense and very massive for such a small space. So and yeah, if I put a text here, yeah, where we might be, where Earth. So Earth or the sun, yeah, where we are. So yeah, and if we have another line, in fact, I'll do like I'll do these as like neutron stars, because neutron stars I used to see them in documentaries. They're quite they're red for some reason. Don't know why, but probably the way how light absorbs. So neutron star. Yeah, if you notice, it says neutron star. You know, neutrons are made of like make up atoms. I think it's when all the electrons and the protons all crush together and all and all the neutrons too, and they all form this. It's all formed of neutrons and stuff. But I'm not sure. So, but yeah, that's kind of how it works. Yeah. So yeah. So we covered neutron stars, black holes. We've covered the length of a typical galaxy. Oh yeah. Also, we've got like forget this. I'll do it orange. We've got like areas where called nebulae. Now, nebulae are like star forming regions, so where new stars are being made. Yeah, sometimes we can see them in telescopes. We can actually see new stars being made, new planets, new like moons and stuff. Really good. But yeah, we've seen stars for definite. I'm not sure if we've seen planets, but probably have. So yeah, they are quite beautiful places as well. They all all these nice colours and everything. Really good. So yeah, we have that, and so we have nebulae, black holes, the supermassive black hole at the centre, stars. I think that's about it for the sort of like average stuff we might be having. But I'd like to talk about how, like, why the galaxy is the way it is. Why is there a structure? Like, why isn't it just all dispersed? Now, you might be thinking the supermassive black hole keeps it all together, but no, that's not true. Because it doesn't have enough strength in terms. It is strong, the black hole, but it doesn't have enough strength to keep all that energy and mass. It doesn't. It's stretches of its own gravity doesn't affect like literally hundreds of thousands of light years away. It doesn't. It's not as powerful it is. It doesn't affect such a large area. It can't do. It can't keep them all together. So, what is going on? Well, in astronomy, they have this. It's called dark matter, and it's what holds the galaxy together, and it's what holds all the galaxies together in the universe. Otherwise, if they weren't held together, all the stars, all the neutron stars, whatever there was a structure, would just fly away. So, yeah, it's important that is very, very important. So yeah, this is a general overview of what galaxy. I'll actually just while I'm here, I'll just put nebulae. Yeah, general overview of a typical galaxy. There is this is sort of generally what you have. It's not true with all the other galaxies. You know, it can varies a lot, but this is what sort of things you will have in a typical galaxy. So yeah, I hope that was useful. I'll have more discussions on this, and I hope you have a good day, and hopefully this video was helpful. Thank you.